group and hence the process is alkylation. Here there is introduction of acyl group and hence the process is called as acylation. The last two are the naming reaction. This is nothing but Friedel-Crafts reaction. Friedel-Crafts reaction. Since here there is introduction of the alkyl group, so I say as Friedel-Crafts alkylation, acyl group, so Friedel-Crafts acylation. All this you have studied in class 11th. I am just going to make use of this concept in this part. Here now into the 12th standard. I hope this part is clear. The last two are naming reaction. There is a correction here. This is Friedel-Crafts. This is Friedel-Crafts reaction. Now just look here. Suppose I have got a phenol. There is a group attached to the ring. There was no group attached to the aromatic benzene ring here. Here I am taking another compound, carboxylic acid. I hope everyone remembers the name. The first one is phenol. Here this part is benzoic acid, carboxylic group attached to the benzene ring. Now suppose the question is given like this. What happens when phenol reacts with concentrated HNO3 and concentrated H2SO4? Or what happens when phenol reacts with nitrating mixture? Phenol part remains as it is. I hope you remember this carbon atom becomes sp2 hybridized and it is not easy to break the bond between the ring and the group attached. I have just kept it like this. Now since this part I have kept it like this, I am going to treat this one with the nitrating mixture. Nitrating mixture is going to generate which electrophile? Nitronium group. Remember nitronium I told you just now? NO2 positive. So that NO2 group and it has to come and attack the ring. Where should it attack the ring? It can be this position. I hope everyone remembers what is ortho, meta and para. With respect to this, now with respect to the group attached, these two are ortho and these two are meta and this one is para. Now where the NO2 group is going to come and attach? In this case as well as in this case. I am telling in this case it is NO2 here plus there is one more compound I am going to get. I am getting a structure like this, whereas in this case I am going to get the compound like this. Why do I get orthopara in this case? Why do I get meta here? Why the NO2 group is not coming and getting attached here in the ortho position and in the para position? Why in this case the NO2 part is not coming into the meta position? That means the group which is already attached to the ring is the deciding factor. The group which is already attached to the ring is going to decide the incoming group. What is the incoming group? Nitronium ion. Where the nitronium ion is going to come and attack. So I am telling OH group, the OH group is an ortho-para directing group and hence whichever group is going to come and attack, it will always come in the ortho and the para position. Based on this, if I take phenol, I can give you all these reactions, all this reagent, I can do everything. Now here, if I ask you what happens when phenol reacts with Cl2 in presence of Fe, I am going to get Cl here, Cl here, HNO3, NO2 here, NO2 here, H2SO4, SO3H here. Like this. Similarly, I can ask you the question, what happens when phenol undergoes Friedel-Crafts alkylation? Can you identify what will be the product? Phenol undergoing Friedel-Crafts alkylation. Then what will happen? On top of the aroma, you write CH3Cl, anhydrous aluminum chloride, OH is here, CH3 part here, CH3 part here. Similarly, it is not only OH which is ortho-para directing group and hence you should know what are the examples of ortho-para directing group. Ortho and para directing groups. These are also called as activating groups. I am giving you some of the examples. NH2. That means if I just write here NH2, if I ask you what happens when aniline undergoes nitration, I am going to get NH2 here, NO2 as such here, NH2 here, NO2. NH2, I am putting a single bond X halogen, single bond CH3, it can be ethyl, it can be OCH3, OH as such. So if I know at least, if I know all this example, I can complete around some 100 reactions. Like for example, to the ring, if I attach OCS3, what is the common name for that? To the ring, if I attach OCS3, methoxybenzene, the common name for this one is anisole. Suppose in the examination, this is the question asked, what happens when anisole undergoes Friedel-Crafts alkylation reaction? How do you write? First you write down, what is the reagent for Friedel-Crafts alkylation? CS3Cl, anhydrous aluminum chloride. Next, find out what group is going to be generated from that. It is CS3 part. Where it has to come and attack? For that, I have to see what group is attached to the ring. OCS3 is attached. Where is OCS3? OCS3 is an example of an ortho and para directing group. So, I am going to get the product this way. I can, I'm sorry, here I am going to get this part and OCS3 here and the para. That means I am getting orthomethyl anisole and paramethyl anisole. I can do numerable reaction, and you can see that most of the reaction involving the ring is completed in that way. Similarly, when I come to the carboxylic acid group, I am putting it into the meta position. The same concept. This group, this part is going to generate nitronium as an electrophile. So, the nitronium group is going to come and get attached at the meta position. Why? Because carboxylic group is an example of meta directing group, or just opposite of activating, deactivating group. Let me just list down some examples of meta directing, so that like ortho and para, many reactions we can complete. Meta directing groups, which are also called as deactivating group. I am giving some examples. Carboxylic acid, the nitro group. I hope you are able to remember now. Suppose I would have given you nitrobenzene, and the question is asked, what happens when nitrobenzene undergoes nitration? You should be able to make out. Nitro here, nitro here. You are going to get 1,3-dinitrobenzene. Nitro group, aldehyde group, the cyanide group. I have given some of the example. If you remember this, again you can do around some 50 reactions. I hope this much part is clear. If this is clear, I want everyone to turn to page number 399. One of the conversion is given, that is how to convert 4-nitrotoluene to 2-bromobenzoic acid. What you do is, it is a solved example. Whatever compound is given, arrow mark, what part is given? For example, the question is given, it starts with like this, CH3, NO2. I am putting it like this. Okay. Now just look here, it is Br2. Br2 is going to generate what group? Br part. So, the Br part will come and attack the ring where? For that I have to see to the ring, what are the groups already attached? What are the groups attached? I have got a CS3, you have got a NO2. CS3 is coming here, orthopara. NO2 is coming here. NO2 is an example of meta directing. So, if Br has to come, so for CS3 it is ortho, para is already occupied, so it has to be this. So, that means the product part comes out to be like this. If I am taking CS3, NO2, here the Br part. Similarly, for NO2, I know NO2 is an example of a meta directing group. So, the meta position, the NO2 part is going to come. So, this is one meta, this is one meta. So, if I keep it here both for CS3 as well as NO2, I can satisfy. I hope it is clear. And so, whatever is added, just make out whether it is an orthopara or meta directing. And just keeping this concept, keep on turning all the pages, wherever the ring is involved, see the reagent added, you will be able to complete all. I hope with this, the substitution reactions you are able to understand. There are few naming reactions, just Search for all the naming reaction, highlight them, just memorize it. Remember, there are 2 naming reaction, 1 marks each, half mark for the statement and half mark for the reaction. If you know the reaction, convert it in the form of a statement and do it. Most of the reactions I have completed, and wherever certain things have been left out, children, please open the textbook, highlight it and please try to complete it. Now, there is another 2 mark question what you get. I hope everyone remembers 19 marks is organic, 2 marks is meant for the distinguish between the pairs of compound. Now, in the distinguish between the pairs of compound, almost every year we get one of the distinguish is based on iodoform test. Now, what are iodoform reaction, or in general iodoform, chloroform, all rhyming words, iodoform, chloroform, in general haloform. This part you must always remember. For a haloform reaction, what is the necessary condition? For haloform, the organic compound must have methyl keto group. The organic compound must have methyl keto group, or it should have a secondary hydroxyl group. When I say secondary hydroxyl group, suppose I am having a chain like this, I am having something here. This is not going to give me the iodoform test. For the haloform reaction, as I am telling you, the necessary condition is the organic compound must have either methyl keto group or it should have a secondary hydroxyl group. When I say secondary hydroxyl group, you should be very, very careful. Suppose I am having a 7 carbon atom organic compound. The OH group is placed here. This is not going to give me the iodoform test. It should be secondary alcohol, means the OH should be attached either to this position or OH should be attached to this position. Then only that organic compound is going to give iodoform test or the chloroform reaction. Why? Remember, in that oxidation reaction, when I have drawn the chart, 1 degree alcohol gives aldehyde, aldehyde to an acid. Second line I have written, 2 degree alcohol and oxidation gives a ketone. So, on its own, this part gets oxidized to a methyl keto group. Now this chloroform, in your syllabus you have got chloroform as well as iodoform. Chloroform is a liquid, now which can be prepared either from ethyl alcohol in the preparation given. It can be also prepared by a ketone, that is acetone. It can be also prepared by other compounds. Now ethanol and ketone. Now this one, when reacts with Cl2 followed by the hydrolysis NaOH, or the ketone with Cl2 or NaOH hydrolysis. Now hydrolysis, it is not necessary the hydrolysis has to be always done with NaOH. The hydrolysis can also be done with calcium hydroxide. Let me just put here calcium hydroxide, and you are going to get the compound like this, chloroform, and one of the byproduct, here you are going to get HCOONA. In this case, you are going to get the compound as HCOO, oxygen, Ca. Here you are going to get the calcium salt of an acid. In this case, you are going to get sodium salt of an acid. This part you should be careful, because one of the salt organic word problem in the reaction, you are supposed to write this, and thus you must be very careful. If the hydrolysis is with the sodium hydroxide, then the acid is sodium carboxylic, that is sodium carboxylate, and if the hydrolysis is done with calcium hydroxide, then the acid you get as calcium hydroxide. I hope it is clear. With NaOH, the sodium salt of an acid, and with calcium hydroxide, the calcium salt of an acid. It is a liquid. Iodoform is the same thing. Only in place of Cl2, I have to just put an I2 here. Iodoform is a yellowish color solid. I hope this much part is clear. I am going to start with now distinguish between pairs of organic compound. Now suppose you get in the question, distinguish between pentan 2-one and pentan 3-one. So 2-one, it is here. When I write here 3-one, it is here. I have just written here the skeleton structure. I did not put the hydrogen. Now the moment you see this, it is going to give a test of ketone. When both the sides of functional groups are same, I cannot write any of the test. Now in this case, it is the iodoform test. Here you have got methyl keto group. This part do not contains methyl keto group. I am telling pentan 2-one when reacts with NaOH and I2, it is going to give yellow PPT of iodoform. This will not give. I hope this part is clear. In the distinguished test, you must always remember that you must write down only those reactions in which there are some observation changes. Otherwise, you should not write down some theoretical reactions. And once again, starting with the distinguish between the pairs of organic compound, I have just listed here what and all you should know. First one, unsaturation, you have also studied in class 11th. That is the base test with alkaline KMnO4, and another one is the bromine water test. The second one, alcohol test, one can differentiate alcohols with the sodium metal test. Lucas test, 3 different observations, primary, secondary, tertiary, and the steric ammonium nitrate test where you get a red color. Third one, the carbonyl compound. I hope you remember carbonyl compounds, aldehydes and the ketones. It is giving 2,4-DNP test, red color. Then I have written here certain 2 tests, Fehling's and Tollens, which are only given by aldehydes, whereas sodium nitroprusside test is only given by the ketone group. You must remember that aromatic aldehydes do not give Fehling's test. Like suppose the question is asked, distinguish between acetaldehyde and benzaldehyde. Both the sides of functional groups are same. I cannot write any of the tests for aldehyde. In that case, remember, think of certain unusual type of test. There I can say that acetaldehyde when heated with Fehling solution in boiling water gives a red precipitate, whereas benzaldehyde do not. That way you should write down. And always try to make a tabular column. Whatever reagent you are using it, try to underline that, and whatever is the observation, try to underline it. You will be able to score marks. The next one, carboxylic acid test. In the carboxylic acid test, again one of the unusual tests is, it is only the formic acid which gives Tollens test. For example, if it is asked, distinguish between acetic acid and formic acid, then both the side it is carboxylic acid group, you cannot write any of the carboxylic acid test.